we're going to go ahead and do some extra practice with these Newman projections. So to start off, let's have this carbon group, and we're going to say that on the plane or on the sheet of paper itself, right, we're going to have a CH3 group attached. We're going to also have another CH3 group, and this one's going to be going downwards, but also on the plane, attached to the other carbon. Now, for our groups that are going to be facing towards us and away from us, we are going to have a hydrogen group, and we're going to have another hydrogen group, actually. Go ahead. Going out towards the back of this, of the three dimensions, right? Now, here, we're also going to have some group coming out towards us, hydrogen group, and then lastly, we'll have another group attached. The third and final one that we need will be another hydrogen. Now, how are we going to go ahead and draw this as a Newman projection to show where everything is oriented in space, looking at it from this perspective right here, looking at this central carbon. Now, if you remember correctly, we are going to have this central carbon right here. This will be represented like that. And that because we have the CH3 group going downwards, we're going to go ahead and represent it right here like this. And you can go ahead and write CH3. Now, these groups we're going to go ahead and represent the two hydrogens. One is facing towards us, so it's actually going to be represented going this way, hydrogen, and then the group that's going away from us originally is going to be right here. Now, we've represented this portion of our figure, and now we need to represent the back groups right here. And we know that this bond is never going to be actually seen in the Newman projection. Neither is this carbon, only these three groups. Now, we've aligned this molecule in such a way that this CH3 group is opposite to this CH3 group, meaning that when we draw a circle for our new Newman projection, this CH3 group is going to be opposite from this group, so it'll actually be facing up like this. CH3. And then lastly over here we're going to have these groups that are coming out, right? We have this hydrogen group that's coming out towards us, and this group right here is going to be represented on the right. And to make it symmetrical, we'll make it go right here. And lastly, the hydrogen group that's out towards the back, facing away from us, is going to be represented on the left-hand side, right? So we're going to go ahead and draw it right here, coming out. And that is our Newman projection. And it really tells us how these different parts of this overall molecule are oriented in space. Now, this setup is actually very energetically favorable because the large groups, the carbon group with the three hydrogens, are actually further apart from each other. That creates more space. These different branches want to have individual space for their electrons to be oriented and to have a little bit more freedom, you can say. It gives them a high, lets them conserve more energy rather than actually interacting and expending energy with these other groups. So this is a very, very favorable Newman projection, and in further videos we'll actually describe how a little bit more about the steric hindrance and how certain groups don't want to be next to each other or consume a lot of energy if they are next to each other. So thank you for watching, and we'll catch you in the next video.